Have you ever wondered why Mercury, the smallest and closest planet to the Sun, has been captivating astronomers for centuries? Situated a mere stone's throw from our solar system's fiery heart, Mercury is a world of extremes. A petite powerhouse enduring searing heat, a barren landscape etched with countless craters. This celestial body, with its hot, dry surface, appears almost alien in its starkness. Known to ancient astronomers, Mercury's charm has been enchanting those who gaze upon the stars for centuries. It was first spied through a telescope by none other than Galileo Galilei in the 16th century. This tiny, tantalizing planet, whirling in its swift orbit around the Sun, has always been a source of fascination and curiosity. Its size belies the wealth of secrets it holds, and its proximity to the Sun only adds to its enigmatic allure. As we delve deeper into the cosmos, our understanding of Mercury continues to evolve. Mercury's mysterious allure has only increased with time, sparking interest and leading to numerous missions to understand it better. The 19th century brought about significant revelations about Mercury. This period was marked by a major shift in our understanding of this enigmatic celestial body. Through the lens of telescopes, astronomers of the era peered into the heavens and made startling discoveries about the smallest planet in our solar system. Their observations revealed that Mercury, far from being a smooth and featureless sphere, was a world deeply scarred by cosmic impacts. Its surface was a vast, sprawling landscape of craters, a testament to the eons of meteoric bombardment it had endured. This was a stark contrast to earlier assumptions that perceived Mercury as a relatively unblemished celestial body. But that wasn't all. As astronomers turned their gaze upon this sun-hugging planet, they found something else, or rather, the lack of something else. Mercury, as it turned out, had no discernible atmosphere. This lack of an atmospheric blanket meant that the planet was exposed to the harshness of space, enduring extreme temperature fluctuations and constant solar radiation. This was a far cry from the earlier belief that Mercury, like Earth, may possess a protective atmospheric layer. These 19th century discoveries painted a picture of Mercury as a world of extremes, a planet that endured a punishing existence as the closest planet to the Sun. But instead of settling the mysteries of Mercury, these revelations only added to them. Why was Mercury's surface so heavily cratered? How could a planet so close to the Sun lack an atmosphere? These findings only deepened the intrigue surrounding Mercury, prompting further study and exploration. The 19th century discoveries set the stage for the future, igniting a spark of curiosity that would lead to numerous missions aimed at unraveling the secrets of this fascinating planet. The quest to understand Mercury led to the launch of several spacecraft, including Mariner 10 and Messenger. The Mariner 10 spacecraft, launched in the year 1973, was the first to pay a visit to Mercury. It was an ambitious journey, given the planet's proximity to the Sun and the intense heat and radiation that comes with it. But Mariner 10 was up to the task, equipped with a protective sunshade and a mission to capture the first close-up images of the planet's surface. Mariner 10 managed to accomplish a great deal. It discovered that Mercury has a weak magnetic field, a surprising find considering the planet's small size and slow rotation. This revelation suggested that Mercury has a partially molten core, a theory that would later be confirmed by the Messenger mission. Mariner 10 also revealed Mercury's incredibly thin atmosphere, known as an exosphere, made up of atoms blasted off the planet's surface by solar radiation. Fast forward to the year 2004, and we have the launch of Messenger, an acronym for Mercury Surface, Space Environment, Geochemistry, and Ranging. This spacecraft was designed to answer several key questions about Mercury, such as the planet's geological history, the nature of its magnetic field, and the composition of its surface and thin atmosphere. Messenger exceeded all expectations, orbiting Mercury for 4 years and providing a wealth of information. It confirmed Mariner 10's findings about Mercury's magnetic field and discovered evidence of water ice in permanently shadowed craters near the planet's poles. This was a groundbreaking discovery, suggesting that even in the solar system's innermost planet, water, a key ingredient for life as we know it, can be found. The spacecraft also mapped the planet's surface in detail, revealing diverse terrain with expansive plains, towering cliffs, and deep craters. It found that Mercury's surface is more volatile-rich than previously thought, which challenges our understanding of how the planet formed and evolved. MESSENGER also detected a curious phenomenon known as hollows, irregularly shaped depressions found on the planet's surface. These hollows appear to be younger than the surrounding landscape and are believed to be a result of volatile substances being sublimated or transitioned directly from a solid to a gas under Mercury's intense sunlight. These missions not only advanced our understanding of Mercury, but also paved the way for future explorations. The journey to understand Mercury continues with the Bepi-Colombo spacecraft. This ambitious mission, a joint venture between the European Space Agency and the Japan Aerospace Exploration Agency, took flight in the year 2018, charting a course to the smallest planet in our solar system. Bepi-Colombo's voyage is a testament to our enduring human curiosity, propelling us towards the unknown, even in the face of immense challenges. The objectives of the Bepi-Colombo mission are manifold, each one more fascinating than the last. It aims to study Mercury's structure and composition, to better understand the formation of this tiny, scorched world. It will probe the mysteries of Mercury's magnetic field, a feature that sets it apart from many other rocky planets. The spacecraft will also investigate the planet's exosphere, that ultra-thin layer of gas surrounding Mercury, to shed light on the processes that drive its existence. But Bepi-Colombo is not just about understanding Mercury in isolation. The spacecraft's findings will contribute to broader questions about the formation of our solar system, about how rocky planets evolve over time, and about the possibilities of life existing elsewhere in the universe. The Bepi-Colombo mission is also a marvel of engineering. The spacecraft is equipped with a suite of 11 scientific instruments, each designed to withstand the extreme temperatures near the sun. It's a testament to our technological prowess, a reminder of how far we've come in our quest to explore the cosmos. As we look forward to 2025, the year Bepi-Colombo is set to arrive at Mercury, we can't help but feel a sense of anticipation. What secrets will this mission uncover? What new questions will it prompt? Only time will tell. Bepi-Colombo is expected to shed more light on the mysteries of Mercury, bringing us closer to understanding this fascinating planet. The exploration of Mercury is far from over. As we venture further into the mysteries of space, our curiosity about Mercury, the smallest and closest planet to the Sun, continues to grow. The upcoming missions to this enigmatic celestial body promise to reveal new insights and deepen our understanding of our solar system. First on the horizon is the Mercury Planetary Orbiter and Sample Return mission. This ambitious project aims to take our exploration of Mercury to the next level. Not content with simply observing from a distance, this mission plans to land on Mercury's surface and collect samples. These samples, once returned to Earth, could provide invaluable data on the planet's composition, history, and potential for future exploration. The mission's primary objective is to understand the origin and evolution of a planet close to the parent star. By studying Mercury, we'll be able to learn more about the early solar system and the processes that govern the formation of terrestrial planets. Next, we have MESSENGER 2, a follow-up to the successful MESSENGER mission. Building on the discoveries of its predecessor, MESSENGER 2 aims to delve deeper into the mysteries of Mercury. The mission will focus on investigating the planet's magnetic field, geology, and surface composition. It's hoped that this mission will provide answers to some of the lingering questions left by the first MESSENGER mission. Together, these missions represent the next chapter in our exploration of Mercury. Each mission has its distinct set of objectives, but they all share a common goal: to unravel the mysteries of Mercury, and in doing so, broaden our understanding of the universe. As we continue to explore Mercury, this small but intriguing planet promises to keep revealing new secrets, ensuring that our journey of discovery is far from over. Mercury, the smallest planet in our solar system and the closest to the Sun, has been a subject of fascination for centuries. From its hot, dry, heavily cratered surface to its lack of atmosphere, Mercury's unique characteristics have captured our interest. Our understanding of this enigmatic planet has been shaped by discoveries from the 19th century, when astronomers first observed Mercury's cratered surface through telescopes. The Mariner 10 and Messenger missions further deepened our knowledge, providing crucial insights into Mercury's composition, topography, and environment. Bepi Colombo, launched in 2018, is set to arrive at Mercury in 2025, promising a new era of discovery. Looking ahead, future missions such as the Mercury Planetary Orbiter and Sample Return and Messenger 2 aim to further unravel the secrets of this fascinating planet. As we continue to probe Mercury, we can only expect to unravel more of its mysteries, making it a captivating subject of astronomical exploration.